Okay, so what we're going to look at is the heat of formation. Now, what is that? So we have our definition here in red, and it's the heat change that takes place when 1 mole of a compound in its standard state is formed from its elements in their, so that should be in their standard states. So let's just break that down. So the heat change, if you look at the example, whenever we react things together, we have the potential energy or the heat energy of the reactants, and then we have another energy or heat energy of the products. Okay, so you'll often see energy profile diagrams where if the heat, let's say energy is here, and the progression of the reaction is down here, we can see that there is a difference in heat for the reactants versus the products. So here we've lost energy, which means it's an exothermic reaction. Energy is being given out. Now, if we have an endothermic reaction, it means we have gained energy because we're taking in energy from the environment around us. So as every reaction has a change in energy, every heat of formation, when things are formed, that also goes through an energy change. So let's take a look at the first one. It says when 1 mole of a compound in its standard state is formed. So you see here, H2O, we are forming H2O with hydrogen and oxygen. And you can see that there's an imaginary 1 in front of that H2O. That means we have exactly 1 mole of water that's being formed. So that's one of the rules that we have to look at, that we can only have 1 mole of the substance being formed. Now in its standard state, so if you look over here in the purple, standard state is the state of the elements and the compound at 25 degrees Celsius and 101 kilopascals. Okay, so it's not standard temperature and pressure, it's a standard state, so don't get those two confused. So it's easy enough. So think about hydrogen gas, or H2. That's a gas at 25 degrees Celsius. So that G here represents the state of that molecule there. Oxygen is a gas at 25 degrees Celsius. And is H2O a gas at 25 degrees Celsius? No. So that is going to be a liquid. And if something was a solid at 25 degrees Celsius, you'd put in small little brackets S. Okay, so they all represent the states of those compounds at 25 degrees Celsius. So let's read the definition again. The heat change that takes place when 1 mole of a compound in its standard state is formed from its elements in their standard states. Okay, so we have H2 here because hydrogen always comes in a molecule. It always comes naturally as H2. And the exact same with oxygen, O2. Now you might be thinking to yourself, we don't usually see that equation looking like that. We'd never have a fraction in there beside the oxygen. It would usually look like this. But that's going against our definition. We are here creating 2 moles of water rather than 1 mole of water. So that's why we have to introduce fractions in our equation. So from this formation of water, you can see over here the delta H, we have lost energy So our reactants have lost energy as they've formed the water. And we can see they've lost 285.8 kilojoules per mole. Okay? If it was a positive 285.8, they would have gained energy. Okay, so let's look at our question. So, calculate the heat of formation of ethane from the following data. Now, you might not get the formula. Here they've been very generous and they've given you the formula C2H6. You should know your prefixes, and if something is given to you in English, a naming of a compound, you'll have to be able to figure out the formula, the chemical formula of that compound from the English sentence. So let's say if they didn't give you C2H6 and they said ethane, calculate the formation of ethane, you would have to know that that is C2H6. Okay, so it's given it to us, so let's just see what it's asking. Okay, so we have to come up with some energy, the heat of formation, how much energy is lost or gained when ethane is formed. So they've given us 3 equations with 3 heat changes. When we do these questions, we first of all need to write out the original equation using just the elements in their standard state to make 1 mole of the compound we're looking for. So basically we have to come up with something like this. Element, element, and 1 mole of the compound. So let's write down C2H6 is what we're looking for. And that is in a gas. So now, all you have to think about is what elements are in C2H6 and how do they come about naturally. So carbon comes as a single atom and it's a solid. Hydrogen always comes in a molecule format and it's a gas at 25 degrees Celsius. Now we just need to balance it. 2 carbons and 3 hydrogens. Okay, so that's that part done. And we've kept the rule of only having 1 mole of the substance on that side. So from the 3 equations that I have in the question, I need to try and make those 3 equations look like the equation I'm just after writing down. So the first step is to look at each sentence. I want to see if my reactants are on the right side and if my product is on the right side. And you'll see what I mean now in a minute. So the very first one, let's look at what's in there. I'm interested in the carbon. Okay, so you can see I have a carbon here and I have a carbon right here. Now, there's only 1 carbon in that equation. I want 2. So what I have to do is multiply that line by 2. And the whole line needs to multiply by 2. So once I do that, I'll get 2 carbons, 2 oxygens, goes to 2 CO2s. And I have to remember to multiply the heat of formation of that reaction by 2 as well. So if I do that, I'll get minus 787 kilojoules per mole. Okay, so you can see we're trying to basically build up this reaction here from the equations we have. So I've got carbon, that's fine. Let's move on to the next one. I have a hydrogen, another oxygen, and water. So out of that, I'm interested in the hydrogen. I don't want 1 mole, I want 3 moles. So I multiply that line by 3. So 3H2. That'll be 1.5 oxygens. And we'll have 3 waters. And again, remember to multiply your heat of reaction by 3 as well. Okay, the last one. So I have my ethane there, which is good. And you can always look at the reactions to give you a hint. Like let's say if I didn't actually have this and it said ethane, take a look at these equations and you'll get a hint from that equation. Like you'll probably know that carbon's carbon, oxygen is oxygen, carbon dioxide is carbon dioxide, and water is water. So you're looking for the formation of that, but only 1 mole of it. So check out those hints before you start into a question. Okay, so the last one. I'm interested in 1 mole of ethane. At the moment I have 2 moles there, so I need to fix that. But also, ethane is on the wrong side. It's not on the products side, like in my equation, it's on the reactant side. So I need to do a reverse. And also, it's not 1 mole, it's 2 moles. So I need to divide it by 2. So reverse and divide by 2. So let's do that. What I mean by reverse is you move the products here over to the other side, and you move the reactants over to this side. Okay? So you take everything on the left hand side, move it to the right hand side, everything on the right hand side, move it to the left hand side. So I'm going to do that, and at the same time I'm going to divide it by 2. Okay. So instead of getting 4 carbon dioxides, I'll have 2 carbon dioxides, 3 waters. So I've moved those products over to the reactant side. I'll have 1 mole of ethane and 3.5 of oxygen. Okay, so if that step was a bit too fast for you, reverse back and look at it again. All I've done is divided everything by 2 and flipped my products to the reactant side and vice versa. Now don't forget to work out your new heat of formation. So all of the time, the 2 previous ones, we've kept the minus sign. We've kept what was there and we've multiplied it by 2 or 3. So that's fine. If you reverse an equation, you have to change the sign to a positive. So instead of being minus, it's going to be a positive now. Also, we divide it by 2. So divide that 3119.6 by 2, and you get 1559.8 kilojoules per mole. Okay, that's the hard part done. Now I just want to double check. So to double check, I'm going to circle that I've successfully gotten every part of my original equation within the 3 lines I've just drawn in. So I wanted 2 carbons, I wanted 3 hydrogens, and I wanted 1 mole of ethane. So that's good, we've got all that done. The next step is to check if the rest of it cancels out. So 2 carbon dioxides, 2 carbon dioxides, either side of the arrows. 3 waters, 3 waters, again either side. Over here I have 2 oxygens and 1.5. If I add those together, it's 3.5. And I have 3.5. everything else is cancelled out. And what we're left with is the elements and the molecule of the original equation. So I know I've done it correctly. Last step is adding up these 3 heats of formation to get the heat of formation of this equation. So if you add minus 787, minus 857.4, and plus 1559.8, you will get a heat of formation of minus 74.6 kilojoules per mole. And that's the amount of energy that is lost when you form 1 mole